Quadratic inequalities. And as you know, quadratic inequality is a mathematical statement that relates a quadratic expression as either less than or greater than another. So here, a quadratic inequality in one variable is an inequality that contains polynomial whose highest exponent is 2. The general forms are the following, where a, b, and c are real numbers, with a greater than 0 and a is not equal to 0. So we have here four different quadratic inequalities. Ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is less than 0. Ax squared plus bx plus c is less than or equal to 0. And lastly, ax squared plus bx plus c is greater than or equal to 0. In solving quadratic inequalities, we need to find its solution set. The solution set of a quadratic inequality can be written as a set and can be illustrated through a number line. And then remember, if you're going to use the symbol less than or greater than, you're going to use hollow circle, and it means the critical points are not included. While if the given inequality is less than or equal to and greater than or equal to, then you're going to use solid circle. The critical points are included. Let's have our first problem. Find the solution set of 3x squared minus 8x plus 5 is greater than 0. So first, let's copy our problem. Next, we need to replace our inequality symbol to equal sign. Alright, now we can solve this equation using our method in solving quadratic equation. I prefer using factoring. So by using factoring, I'm going to multiply a by c. So 3 times 5 will give me 15. So I'll be making here my sketch. So you can see how I factor this number. And before factoring, you need to consider the value of b. We have here negative 8. So it means the sum of the factors should be negative 8. So in this case, if I'm going to factor 15, I can have 3 times 5. But adding 3 and 5 will not result to negative 8. But what if I'm going to add a negative sign here and here a negative 5? So now I have here negative 3 times negative 5 is also equal to positive 15. And at the same time, if I will add the two factors, negative 3 minus 5 is equal to negative 8. So this will be my factor. Then I should put here below of our equation x and some open parentheses and close parentheses equals 0. So next, before I write the number here, take note that the value of a here is 3. So therefore, I need to divide my factors by 3 before writing it on the factors. So simplifying, I'm going to have here negative 1. Then the other one is negative 5 over 3 since this already in its lowest form or lowest term. Next, I can now write this one here. So x minus 1. Then the other is x minus 5 over 3. Now, applying zero product property, I'm going to have here x minus 1 equals to 0. And then the other is x minus 5 over 3 equals 0. Now, let's solve for x. So here on our x minus 1 equals 0, this will give us x equals 1 by APE. And at the same time, for x minus 5 over 3 equals 0, that will also give me x equals 5 over 3. Now, we have now obtained our critical points. So allow me to erase this one. Let's have here a number line. So on our number line, we're going to plot our critical points. So we have here 1, integer 1. The other one is 5 over 3 or 5 thirds, or it is also equal to 1 over 2 thirds. So it means it is located on the right side of our integer 1. So I'm going to write here 1 and 2 thirds. Next, as you can see, we're going to create our intervals using the critical points. So here on the left side of our number line, the interval here is x. Since our symbol has no equal sign, so we're going to use here x is greater than, rather x is less than 1. And on the middle part of our number line, the interval here is x is greater than 1 but less than 1 and 2/3. So let's put here some parentheses so you can identify those intervals. And on the right side, this is going to be x is greater than 1 and 2/3. If you get confused with the symbol here, for example, in x less than 1, you can see the arrow here. Since it is on the left side, look at the arrowhead. The arrowhead is going to the left. So it means you're going to use that head of the arrow. Also for the right side of the uh, number line. So we have here x is greater than 1 and 2/3. Since the arrow here is going to the right, the arrow on our inequality is going to the right. So now we're going to test here which interval will satisfy our solution. So let's go back with our original inequality. So we're going to test our points. So copy again. If I'm going to test here, first let's pick a number here. So pick a number that is less than 1. Number less than 1 is, maybe I can choose 0. So let's test here. So let's have our test point as 0. Test point 0. And then we substitute 0 to our original inequality, which is 3x squared minus 8x plus 5 greater than 0. So this is going to be 0 minus 8 times 0, forget the squared, plus 5 greater than 0. So 0 squared times 3 is 0. Negative 8 times 0 is still 0. Then plus 5. So it means here we can have 5 is greater than 0, which is true. So therefore, here, this interval satisfy our solution. So this will be our answer here. This is one of our answer. So let's put here an arrow. And since our symbol here is our inequality symbol is greater than, so it means we're going to use a hollow circle. So let me put here an hollow circle. Next, let's try to test the inside of our number line. So test point, pick a number that is inside here. Maybe I can use 1 and 1/3. So my point here is 1 and 1/3. Or I can use to make it improper fraction, so I can easily substitute it on our equation or with our inequality. So I'm going to use 4/3. So again, let's write our inequality, 3x squared minus 8x, or rather, let's directly substitute it on our original equation. So we can have here 3 times 4/3 squared minus 8 times 4/3 plus 5 is greater than 0. So let's solve for this one. So this is going to be 3 times 16/9 minus 8 times 4 is 32/3 plus 5 greater than 0. So I can have here 3 times 16/9. That will give me, of course, I can cancel out here, like 3/9 will give me 3. So I could have here 16/3 minus 32/3. Then I'm going to change this 5 to plus 15/3. So I can easily solve all of these numbers, like 16 minus 32 will give me negative 16 plus 15, that will give me negative 1/3. And as you can see, this is not true. Since this is false, we're not going to put any line here. So this middle part of our number line is not a solution set of our inequality. So last is to test the right side of our inequality. So now our test point here is test point. So let's choose greater than 1 and 2/3. Maybe I can choose 2. So test point is 2. Using 2, substitute that to our original inequality. 3 times 2 squared minus 8 times 2 plus 5 and greater than 0. So we have here 3 times 4 minus 8 times 2 is 16. So negative 16 plus 5 greater than 0. And then 12 minus 16 plus 5 is greater than 0. Or this will give us 12 minus 16 is negative 4 plus 1 is 1. So we have here 1 is greater than 0. So therefore, this is true. Since it is true, our answer here, we need to put here an hollow circle since the symbol is greater than, and then put an arrow going to the right. So that's it. We have now our graph. And of course, if you want to know our solution set, the solution set here is x is less than 1 or x is greater than 1 and 2/3. So let's write here on the below. So I'm going to write here solution set. Solution set is x such that x is less than 1 or x is greater than 1 and 2/3. And that's it. We have now obtained our solution set and also the graph of our number line. Also, remember this procedure in solving quadratic inequalities. First, transform the given quadratic inequality into quadratic equation. Make sure to express it into standard form. Like what we had done, we replace the inequality symbol to equal sign. Next, solve for the roots or the critical points. You may use different methods in solving quadratic equations. So you can also use quadratic formula or completing the square aside from factoring. Number 3, use the roots, critical points to obtain the intervals. So next, we plot those critical points on our solution set. So choose a test point in each interval to determine the solution set. So after plotting the critical points, we identify the interval and then we test some points on our intervals. Of course, you will obtain 3 intervals every time you do this process. And then graph the solution set. Depending on the inequality, if you're going to use hollow or solid circle. And of course, don't forget to highlight those lines that satisfy the solution set. And lastly, check the obtained solution set in the original inequality.